Good afternoon, ma'am.
Mike have to, yes.
Good afternoon to everyone, and thank you for joining us on the day 5 of this faculty development program on quantum computing. We are thrilled to have you all here today as we continue to explore new methodologies and tools that can empower us as educators. Throughout this program, we will have the opportunity to dive into the practical applications that enhance both our teaching approaches and the student learning experience. Let us continue to share, learn, and grow together as educators. Before we move on to the today's session, I'm honored to introduce our esteemed guest, Dr. P. Shanmugavadivu. Dr. P. Shanmugavadivu is an accomplished academician with over 3 decades of experience in the field of computer science and application. She currently serves as a professor at the Department of Computer Science and Application, the Gandhigram Rural Institute, Dindigul, Tamil Nadu, India. Her academic journey is marked by her extensive qualifications, including a PhD in computer science from Gandhigram Rural Institute, where her research focused on adaptive median-based filters for restoration of still images corrupted by impulsive noise. She also holds a master's degree in computer application from the prestigious Regional Engineering College, Trichy. In addition to her expertise in computer science, she has recently completed an MTech in data science and engineering from the Birla Institute of Technology and Science, as well as MBA in 2017 from the Indira Gandhi National Open University. Moreover, she holds a master degree in psychology, which enhances her ability to explore the intersection of technology and human behavior. Throughout her career, Dr. Shanmuga Badigal has actively participated in various professional development programs, including the Leadership for Academician program at IIT Bombay and Young Technological University, Singapore. These programs have strengthened her leadership skill, equipping her to manage academic and research endeavors effectively. She has authored numerous of research papers and has been active participant in workshops related to scientific writing and research ethics. Her leadership in academics is also evident in the mentoring of students, where she guides them through the complex research projects, especially in the field such as image processing, data science, and medical data analytics. Dr. Shanmuga Vadiva's contribution to both research and teaching have had a lasting impact on her field, making a respected figure in computer science and its interdisciplinary applications. She has been actively involved in various prestigious academic conferences and leadership programs throughout her career. Some of the notable engagements include her participation in the International Conference on Business and Industrial Research held in Bangkok, Thailand in May 2023, and her role in the Leadership for Academician program at Nanyang Technology University, Singapore in March 2019. Her research has also been showcased at the conferences such as International Conference on Electronics and Electrical Engineering, China in 2018. She has also contributed to the International Conference on Robotic Vision, Signal Processing, and Power Applications in Malaysia in 2013. In addition to her academic achievements, Dr. Shanmugavadigal has received several awards, including the Best Paper Award for her work on optimized deep neural network architecture for cancer diagnosis. In the terms of corporate responsibilities, Dr. Shanmugavadigal holds several important roles at the Gandhigram Rural Institute. She has been the director of Internal Quality Assurance Cell since November 2017 and also served as a local coordinator for the UGC New Delhi since 2015. She is also an active member of various institutional committees such as Disciplinary Committee, Advisory Committee for the School of Education, and many more. She has made a remarkable contribution to the field of education, research, and leadership. Her exemplary work as a researcher and the had earned many awards, including Best Paper Award, and also has been recognized as the top 20 influential women educators in Tamil Nadu. It is an absolute honor to welcome a truly distinguished and accomplished individual, Dr. P. Shanmugavadivu, to speak us with today.
Very pleasant good afternoon to every one of you. First of all, my apologies to the organizer for having put them into trouble asking for postponement instead of having it in the morning, and they have arranged in the afternoon. My apologies to the organizers of this faculty development program as well as the participants, because I had to attend a kind of unexpected meeting in the morning. I was supposed to do that. However, I'm very happy to get connected to Rathinam College of Arts and Science for the first time, and I thank my thanks to all the organizers who constantly uh, got in touch with me to get this task done. I thanks to Dr. Dhanush, Dr. Oma, Dr. Karthi, and all of them who meticulously could help me to conduct this program successfully, this session successfully. I think you are traveling um, in all previous sessions based on the principle of quantum computing for the next generation. So as a computer science faculty, my duty and responsibility is to make you understand how this quantum computing will influence artificial intelligence, which is one of the most prominent technology, I could say. We can call it as a replacement technology or transformative technology or disruptive technology. You can call it by any name. But however, this artificial intelligence itself is a big bang on the traditional technology. Now, this artificial intelligence is taking different variations in the form of quantum AI, which is very interesting to know. So, this session is going to be on quantum artificial intelligence and applications. Now, to make you understand or to take you to quantum artificial intelligence, it's very important to highlight on all the essential aspects of artificial intelligence. Only then you will be able to correlate how best this artificial intelligence can be dealt with in the flavor of quantum computing. So with this small introduction, please permit me to go to my PowerPoint presentation. I hope you are able to see the screen.
Yes, ma'am.
Okay. So if you are not able to, because now I have gone to the display mode, I may not be able to track the status. Suppose if that gets cut, or if you're not able to see the PowerPoint presentation, or if you don't hear my voice, please call to my mobile phone. Thank you. Now this session is on quantum AI, quantum artificial intelligence and applications. Now to begin with, the plan of our pathway, AI and introduction, machine learning, deep learning, transfer learning. Then we'll be touching upon quantum artificial intelligence and its essential aspects. And now you must be knowing about this personality. He is John McCarthy, who is known as father of artificial intelligence, all because he is the one who coined the term artificial intelligence. So he says it's a top-down approach. A top-down approach was dominant at that time, pre-programming a computer with rules that govern human behavior. This is the information that is given um, based on their understanding about artificial intelligence, about smarter machines. Now we talk about smart watch, smart washing machine, then smart oven. You just name any appliances, we prefix it with smart because it's able to give us some kind of signal when needed, or it is able to take decisions on its own, all because of the presence of a small quantum of artificial intelligence in it. So um, it is all about artificial intelligence. The whole world is revolving. Now, if you sit with writing an email, you get a lot of suggestions. It is all because you have got the most interesting component, artificial intelligence, in it. And if you just go through certain shots, like whatever you get in your mobile phone, then repeatedly you get similar kind of subjects. It is all because you are being watched by artificial intelligence, and advertisements are being personalized. It's because of artificial intelligence. Now when you go for say online shopping, e-business, and when you purchase something repeatedly, you get a lot of prompts on purchasing the same product, and they try to influence you. It is all because of artificial intelligence. So knowingly or unknowingly, consciously or unconsciously, this artificial intelligence is revolving all around us. And when this artificial intelligence takes a new turn in the form of quantum computing, it is very important for all the teachers, especially teachers of higher educational institutions, to travel along with the technological advancements and technological transformation. It's very important. Okay, what do you think about artificial intelligence? What do you think artificial intelligence is? So every one of you must be having some basic understanding about this artificial intelligence. So however, to have a kind of just to have a kind of free flow of the session, let me start with the definition of artificial intelligence. So these are all is the expression of Sundar Pichai on artificial intelligence. AI is a main tool behind new age innovation and discoveries like driverless cars and disease detecting algorithms. And Barack Obama, former president of the US, the results of USA is taunting every one of us. The success of Trump and the victory of Trump, all these things. But Barack Obama, he talks about artificial intelligence. Generalized AI is worth thinking about because it's our imaginations and it gets us to think about our core values and issues of choice. Then Elon Musk, who is also hitting the headline very frequently now, he is a former founder and CEO of Tesla, SpaceX. He says artificial intelligence will vastly smarter than any human would overtake as the human being by the year 2025. 2025 is not far away. It's just 2 months away, less than 2 months away. Then Bezos, who is founder and CEO of Amazon, he says we are now solving problems with machine learning and artificial intelligence that were in the realm of science fiction for the last several decades. So, to be very precise, the gist of all these statements is whatever we thought to be impossible is made possible with the power of artificial intelligence. Number one. Then number two, the second thing is whatever we just happen to understand in the form of science fictions, and whatever we saw, excuse me, whatever we saw in the form of uh, whatever we saw in the movie, like science fictions, as all of us must not have forgotten about Yendran, like who was we just happen to see a robo overtaking the best efforts of a human or his own inventor. So these are all were looking little fussy and appear to be impossible. But however, after the invasion of artificial intelligence, things have become totally possible now. Now we are able to understand each and every point of this is possible with the support of artificial intelligence. So now the point is that how best we can integrate all these things in the form of or in the new flavor in the form of artificial intelligence. So now let us see what is the future of this artificial intelligence, or how we can integrate this artificial intelligence. And by the way, the very purpose of going for or attending this faculty development program is point number one, to keep us abreast with changing technological advancements. Number one. Number two, to get the possible inputs on this changing environment so that we will be able to incorporate or integrate these new components in the best possible way so that we will be able to come out with innovations and new thoughts and new discoveries, new outcomes as we desire. Okay. So artificial intelligence, according to the definition of Merriam-Webster, it's a branch of computer science dealing with the simulation of intelligent behavior in computers, the capability of machine to imitate the intelligent human behavior. So this is how the definition goes. Now, when we just have a deep look into this definition, it is given as imitate intelligent human behavior. So what do you mean by intelligent human behavior? Now you apply your brain, we apply our knowledge for understanding when someone talks. This is what Google does now, Google Translator. We are able to talk back. You have got different translators for different languages. Now we are able to look at an object and try to identify this is a tree, this is an animal, this is a box, etc. That is done with the support of computer vision. Artificial intelligence can simulate computer vision, and when you are capable of taking decisions on your own, you are able to make predictions on your own. So those predictions, decisions, perceptions are possible by the machines. So this is what you call as applying intelligent human behavior. Suppose if we are given a book and if you're asked to read the entire book and write a summary of the book in few pages, then the same thing could be done by means of a machine by the process called text summarization. So when an image is given, we have the intelligence to give a caption for that. Image caption is being done now. Then when you have a low resolution image, that low resolution image can be converted into high resolution, super resolution image. So now we can just go on and on the applications of artificial intelligence. What it does, it imitates human behavior, behaves like a human being. So artificial intelligence refers to systems designed by humans underline that gives a complex goal, act in the physical or digital world by perceiving their environment, interpreting the collected structured and unstructured data, reasoning on knowledge derived from this data, and deciding best actions to take according to predefined parameters to achieve the given goal. So this may look little kind of confusing. I'll give a very simple definition on this. What is artificial intelligence? You have a task to be accomplished. It may be a machine, translation from one language to another language, or disease identification, disease prediction, disease categorization, to identify So when you have this kind of problem for which you give the question space and then give a set of parameters which are used by the artificial intelligence models. Now later as we travel through this session, we get to know what are the different types of models that we can think of. So those models have got predefined parameters because we are not going to define parameters for the computation. We have got set of predefined parameters. Those predefined parameters will understand input and try to achieve the goal. This is the overall understanding of this. So now, what is the need for artificial intelligence? Can't we do everything on our own? Yes, of course. Now, there is a statement that the human brain is much more powerful than supercomputer. But we have a limitation because we have not trained our brain to that extent. And when you have a data which runs to say 1 lakh records, then it's highly impossible for a human being to sit to it immediately in a given a daytime or in a given a couple of. So now, but this artificial intelligence models are very powerful and they are able to solve problem in few seconds, and that is the overall action of artificial intelligence models. So test the human likeness of artificial intelligence with these tests. Now, I think computer science faculty must be knowing about this Turing test, and those interested can I just go and see this invention of Turing machine was the first key step for the science of artificial intelligence. So then the rational agent approach. Whenever you take decision, it should be rational decision. You have to make decisions on evidences and proofs. So the rational approach, then the cognitive modeling, the brain functions, and that is called as cognitive function. So we just decisions as the brain functions. So that approach is called as the cognitive modeling approach. Then the next one is the law of thought approach. Now, when a question is given to all of us, the way that in which I think will be totally or radically different from the way each one of you think. So it's very hard for a person to take or decide or conclude how do I think, how do you think for a given problem statement. So now by taking into considerations all the four contexts, say Turing test, a rational agent approach, cognitive modeling approach, the law of thought approach, it is decided that the computer is able to, not the computer exactly, the artificial intelligence models will be able to take all the best aspects of these approaches, and they're able to behave like a human being in taking decisions, in understanding languages, in doing some natural language processing or disease prediction, weather forecasting, share market prediction. Just name it, it will be able to do it. So now, why we focus more on this AI? This is one of the fastest growing and cutting edge technologies. It has redefined art of computing for problem solving, and it has brought in a paradigm shift in the art of traditional computing. Now we talk about artificial intelligence based problem solving. Offers a spectrum of computing models for problem solving. It is capable of handling big data. So seldom need human intervention. That is, once you design a model, it becomes 100% automatic, and there is no need for us uh, to have any kind of intervention. So AI is ideally suitable for interdisciplinary problems. So please take a note of this, dear participants. Now, the very purpose is all these science faculty have come together. You have to identify a suitable problem so that you can put your brains together and find the best solution out of quantum computing or quantum AI, whatever that you feel like. So then, this is, as we just sailed through this timeline, we could see how fast this artificial intelligence has grown or even outgrown. And it all started in the year 1950 when Turing test was conducted. This is about Turing test is the method for determining intelligence of the machine. It's a test that will make us to understand how far the machine can think like a human being. Then in the year 1995, John McCarthy coined the term artificial intelligence. The term AI is used for the first time in the year 1955. In the year 1966, ELISA was introduced. ELISA is one of the chatbots that simulates the conversations as psychotherapist. Now, when you go to psychotherapist, when someone goes to a psychotherapist, they will ask good number of questions to come to deduce some kind of conclusion on the psychological behavior of a person. So that was automated in the year 1966 in the form of ELISA. Then 1970 to 1908, it is called this AI winter. So after the boom of early research, there was a kind of past, there was a kind of cold storage period for artificial intelligence. Even then, in the year 1997, artificial intelligence came back with a big bang in the name of Deep Blue. That is, this is a supercomputer which was designed for playing chess. Uh, this was able to win against the chess world champion Gary Kasparov. So this made the history, and it made the whole world to look at the power of artificial intelligence. Can a machine play chess? Can a machine behave like a human being? Can a machine be able to take decisions like a human being? Can a machine compete with a human being? So the answer was yes for all these questions in the name of Deep Blue, which was introduced in the year 1997. Then in the year 2011, Siri was introduced. These are all the milestones. 2011, Siri was introduced. Siri is an intelligent speech assistant. I think every one of you must be having in your mobile phone. Is integrated into iPhone 4S for the first time in the year 2011. Then Watson, supercomputer Watson wins against two human rivals in the quiz that show Jeopardy. That Watson is another innovation. Alexa, the virtual assistant Alexa from Amazon, moves into countless homes. Like Alexa assistant we have 2014, 2016. Tay, this is another chatbot. Tay had to be reissued after a short time because of racist and sexist remarks. Right, this was it was withdrawn. AlphaGo in the year 2017, Google's AlphaGo beats the world's champion in the game Go, right? Then because it was for the first version, it was called as AlphaGo. Then 2018, it is ethnic guidelines. The European Union establishes guidelines for dealing with the ethical aspects of artificial intelligence. So this is a quick journey of artificial intelligence. So let's see the evolution of artificial intelligence. In the year 2017, Google researchers developed the concept of transformers in a seminal paper like Attention is All You Need, inspiring subsequent research into tools that could automatically parse unlabeled text into large language model that we call as LLM. Now the whole world is talking about large language model, shortly called as LLM, that came into existence in the year 2017. And parallelly, in the year 2018, OpenAI releases GBT, right? Our chat GBT, that is the overall or the super guru for all the academicians. When you want to write a summary or vote of thanks or introduction, then immediately we just call upon chat GBT. When you have to write an assignment, we just call upon chat GBT. When you have to prepare a program schedule, you just call upon ChatGPT for anything and for everything. Seamlessly, we are using ChatGPT, though that is not advisable. So OpenAI releases GPT, a pre-trained transformer, paving way for the subsequent LLM. Right, and then in the year 2019, Google AI and Langone Medical Center deep learning algorithm outperform radiologists in detecting potential lung cancer. So it was proved that machine can be more accurate than human diagnosis. Then Microsoft launches the Turing natural language generation generative language model with 17 billion parameters, all in the year 2019. In the year 2021, OpenAI introduced the DALI multimodal AI system that can generate images from the text prompt. This is very interesting. Those who are interested can just Google on this. Whatever with the textual description that you give, verbal description that you give, and accordingly that will get converted into an image. Then in the year 2022, DeepMind unveils Alpha Tensor for discovering novel, efficient, and provably correct algorithm. And then in the same year, uh, OpenAI releases ChatGPT in November to provide chat-based interface to its GPT 3.5 LLM. Then the year 2023, OpenAI announces GPT-4 multimodal LLM that receives both text and image prompts. Then Elon Musk and Steve Wozniak and thousands other more signatories urged a 6-month pause on training AI system more powerful than GPT-4. So now they are at their best effort to make the GPT more powerful and on par with human intelligence. So machine learning makes greater inroads into creative artificial intelligence, distributed enterprises, autonomous systems, and hyper automation and cyber security. So these are all the promises AI has. Okay. So now let us have just quick understanding about what do you mean by artificial intelligence, machine learning, and then data science. These are all interrelated. Hope. Machine learning, intelligence demonstrated by machine by performing like human. Machine learning is making predictions with statistical models by recognizing patterns in the data without requiring explicit instruction. So deep learning, this is machine learning method using deep neural network. So now we can say that in machine learning, the degree of learning is, relatively lesser than the degree of learning that happens in deep learning. Then data science, use of statistical techniques to manually extract insights from data. Okay. In data science, we try to see what are the common patterns which are intrinsically present in the data, which can be brought out by the proven set of algorithms. So then data science produces insights, machine learning produces predictions, artificial intelligence produces actions. So deep learning is used on images, videos, natural language text, as well as speech audio. Then data engineering, software engineering. Now this MLOps, right? We must have heard about MLOps. So it is advised that the faculty, computer science faculty, should ensure that this MLOps is introduced in your curricular design, in your programs that you offer. So as you look into it, statistics, linear algebra, calculus, the mathematical aspects, all this kind of approaches form a foundational stone or form foundation for artificial intelligence models, namely machine learning, deep learning, as well as transfer learning. And the other aspect is they have to do certain amount of programming also, like as we do coding. So as you take the models that are present in the artificial intelligence arena, you can categorize them into machine learning, neural network, computer vision, natural language processing, and deep learning. Now, the categories are supervised learning, unsupervised learning, reinforcement learning, supervised learning. So these are all the four major models under the category called machine learning, right? Let us see one after the other. So stages of AI development. Now, when you want to develop a model for problem solving, then artificial intelligence can be organized in several ways depending on stages of development or actions being performed. Let's see the first one. This is reactive machines. Limited artificial intelligence that only react to different kinds of stimuli based on pre-programmed rules, does not use memory, and thus cannot learn with new data. This is very important. So limited artificial intelligence can react only to a limited set of variations inputs, and we cannot have a broader generalization on the model. The best example for reactive machines is we came across this Deep Blue, right, which could beat chess champion Gary Kasparov in the year 1997. It's an example of reactive machine. It has got only specific set of operations meant for doing only chess and not beyond that. And when you talk about limited memory, most modern AI is considered to be limited memory, and it can use memory to improve over time by using trained with new data, typically through an artificial intelligence neural network or any other training model, right? Deep learning is a subset of machine learning and is considered limited memory artificial intelligence. Then theory of mind, how your brain works. In the same way, we have to have the models. Theory of mind AI does not currently exist, but research is ongoing into its possibilities. So then theory of mind describes AI that can emulate the human mind and has decision-making capability equal to that of human, including recognizing, remembering, making expressions, then expressing emotions, understanding other emotions, then understanding a situation and then reacting to it. So all those things are being done by machines with the principle of theory of mind. Then self-aware, a step above theory of mind, AI is self-aware AI that describes mythical machines that is aware of its own existence and has the intelligent and emotion capabilities of human. And like theory of mind, AI self-aware AI does not currently exist. So this is the future of artificial intelligence, is self-aware. Okay. So now let us see what are the general steps that we have to follow when you want to go for creating an artificial intelligence model. First of all, we have to identify the problem to which we have to solve it using problem solving, using traditional computing or artificial intelligence. Now we are going to look into the steps that we have to follow when you want to solve a problem using artificial intelligence. Point number one, we have to define the process. The number two, we have to identify the data source from where we have to collect information. Please keep in your mind, whenever we want to apply artificial intelligence, it is very important to have historical data, or we call it as observational data. What do you mean by this historical data, observational data? Our brain has learned to do language understanding, conversation, and recognizing objects, then remembering, taking decisions, making perceptions based on year-long training it has undergone, either consciously or unconsciously. So every model is making the machine to solve problem by the process of training. So in order to train the model, it's very important to have suitable data set. So identify the data source, and of course you all must be knowing, when you name any kind of discipline, then you can find different number of algorithms which can be trained by large and vast number of data sets. If I want to have data sets on health, they are available. If I want to have data set on commerce, it is available. Then on business, it is available. On government records, it is available. I think all of you must be knowing that there is one website called www.gov.in. So in gov.in, government, all government schemes data are being displayed, and it is in the form of a comprehensive model where we have got set of parameters to be called as input parameter, and one parameter that is called as output parameter. In the case of machine learning, the input parameters are being called as independent parameters, and then the output parameter is called as dependent parameter, because we predict the result or value of the output parameter based on the values of input parameter, which is not true vice versa, because only the output depends on the input and the input parameter is not depending on the output. So you identify the data source, choose the appropriate technology, then train AI model, then test and improve the model, then implement the model and check for the results. This is general steps that one has to follow. So for which we have to have four distinct phases. One is data preparation, second one is AI modeling, third one is simulation and test, and the fourth one is deployment. Let's see what is happening in data preparation. Data cleansing and preparation is taken care in this step, and then we are able to have human insights by looking into the data model, right? We are able to understand what is the purpose of this human insight. Then simulation generated data. Suppose if the data is not sufficient, you can go for simulating the data. Then AI modeling, model design and tuning. We decide the model, and accordingly, because we have got good number of algorithms, right? So you have to select which algorithm you are interested in. So select the model, hardware accelerated training, then interoperability. Then simulation and test. And test, it is integration with complex systems, system simulation and system verification and validation. So we have to simulate the performance of the model, and we have to test the model, check whether it is working well or not. Then once you are satisfied with the performance, then you can go for deployment. You can put this artificial intelligence in an embedded device as you have in the mobile phones, or you can have enterprise system, or else you can have edge cloud computing devices. So now we can just see what are the benefits of artificial intelligence. Now it helps us in automation. It helps to reduce human error, and then it eliminates repetitive tasks. It is fast and accurate. It is available all through 24/7, 365 days once the model is designed, unlike human being. Then the last one is accelerated research and development. So AI can automate workflow and processes or work independently and autonomously from the human team. So for example, AI can help to automate aspects of cybersecurity by continuously monitoring and analyzing the network traffic. Right? So automation is possible without any human intervention. Then the next one is reduce human error. AI can eliminate manual error in data processing, analytics, and assembly in manufacturing and all other tasks of automation because it is known for its accuracy. So instead of doing a task by a human intervention, if it is done automatically, it is expected that the error will be lesser. Then eliminate repetitive tasks. AI can be used to perform repetitive tasks, freeing human capital in work on higher impact problems. See now, this artificial intelligence helps us to handle repetitive tasks as well as complex tasks. Then, whenever we rely on artificial intelligence model, when model is built, then um, there is always possibility that it tries to be accurate as much as possible. Then infinite availability, there is no limit on the time of usage. It is available anytime, anywhere, and so on. And the last one is accelerated research and development. What is accelerated research and development? Now, this artificial intelligence has fueled the research that is going on in AI. The ability to analyze vast amount of data quickly can lead to accelerated breakthroughs and in the research and development. Example, AI AI has been used in the predictive modeling of potential new medical treatments and to quantify the human genomes. See now, it is quite possible. There are a lot of research that is going on. Even presence of cancer cell can be identified through your breath. Right? You can take your breath sample and you'll be able to identify. Then anomalies that develop on the born child after a few years can be identified by means of then biochemical testing and then analyzing those results. Now, suppose if you take biochemical results and if you take the XRD of the sample, from the patterns of the XRD, we will be able to decide whether the model will be able to accurately predict without any kind of difficulty of going for biopsy or anything. So, with the help of this artificial intelligence model, now we are slightly moving towards invasive and non-invasive differences. So now taking biopsy will be first of all painful, then it is time consuming. Whereas this non-invasive is it can be done easily and accuracy is always ensured of. So the real life AI, self-driving car, then Boston Dynamics navigation system that use when you travel, then Asimo chatbot, human versus computer vision or computer games, all these things can be just think of as the elements of artificial intelligence. So then real life AI, personal assistant, then recommendation system, identity system, robo assistant, data visualization, then sentiment analysis and smart payments. These are all some examples. So next we'll see the next one. So now let us have a quick look at the machine learning. Already we have seen this like a computer program is said to learn. Another definition we have seen, and Tom Michel on machine learning operational definition he has given from Carnegie Mellon University. He has given on machine learning. A computer program is said to learn from experience E with respect to some class of task T And performance measure P, if its performance a task in T as measured by P improves with experience E. So the E, T, P, all this will be confusing. Now let us imagine I'm going to develop a model for the for cancer detection, right? Then what is my task? Task is T, that is identification of presence or absence of cancer. This is T. Then there will be a set of measures like accuracy, F1 measure, then confusion matrix. There are certain measures, performance measures associated with the problem that you are dealing with. So those are being called as performance measure is done by means of P, and then it is going to improve the efficiency of the model over a period of time. So that is called as E. So what do you understand from this? Now you have a predefined task to be done for which you have got a set of parameters. Now that parameter value is going to increase, right? When you repeatedly develop the model, when you improve the experience of the model, right? That is done by means of training. Okay, so this is the kind of collage work of all the different types of terminologies associated with machine learning. So machine learning is a subset of artificial intelligence that automatically enables the machine or system to learn and improve from experiences. Instead of explicit programming, machine learning uses artificial intelligence-based algorithms to analyze large amount of data and learns from the insights. What do you mean by insights? By looking at the MRI scan, it is very hard for everyone to check whether there is some abnormality or not. And then whatever that is done by a human doctor, right? Whatever which was done by means of human visual perception, now that is done by means of the machine. So now machine learning is a subset of artificial intelligence and automatically enables a machine or system to learn and improve their experience. This is very important. We should always go for improving the performance of the model. So instead of explicit programming, machine learning uses algorithm to analyze large amount of data, learn from the insights, and then make informed decisions. So this is our outcome. Why do we call this as informed decisions? It should always be rational. It should always be well justifiable with respect to excuse me with respect to the terms and conditions you have for solving the problem. Okay, so then the next one is called as next point is machine learning algorithm improve performance over time as they are trained, exposed to more data. So what do you understand from this particular slide? Now machine learning is a terminology that encompasses a collection of machine learning algorithms. These algorithms are capable of taking the input and make a small kind of a small change or improve it or generalize it or make it better. And if that model's experience is going to help the model to perform better over a time, then that kind of model is called as machine learning model, because it is not learning from the real-time environment. It takes the real-time inputs, then processes it within the environment in which it is operating. So that is called as machine learning algorithm or machine learning model. Now, how can I take a deep dive into machine learning? And the foremost step is that we have to have basic knowledge about statistics, probabilistic, and optimization techniques. So these three are very important to make decisions. And then ML allows machine to learn automatically from the past data. Of course, we can make the machines to understand what is what based on the kind of past data that you have. If I have to develop a model for heart disease identification, I have to collect large amount of data on heart disease, organize it, make it intact and perfect, and then it should be made available for new predictions. And if it is not working well on new predictions, then you have to go for fine tuning the model. So algorithm that can learn from the observational data and can make predictions based on it, then explicitly used to make decisions based on learned parameters and create an analytical model for the future. So please take a note of this. This is what you call as the inflow or the kind of workflow of machine learning model. So if you take the data, then you go for finding the pattern, train the model, produce the output. The accuracy of classification is highly influenced by the nature of the data that is present in the data set. So when the influence of the data is highly distributed and diverse, then probably they may have certain problems like what is the purpose of going for artificial intelligence? For a model, we must be able to provide the data, and the data is going to get processed, synthesized, and then you get some outcome. So that outcome is called as output. The accuracy of classification is highly influenced by the distribution and diversity of data. What is accuracy of classification? Now, when I have 10 records, and if the, the problem is about identifying the person uh, who is not having heart disease, so then you'll be able to just identify out of 10, let us say, eight such prediction or decision are correct, right? Out of 10, 8 are correct. So what does it mean? So the accuracy is as simple as 80 divided by 100, so it is going to be 80%. So now you have the accuracy as 80%, loss is 1 minus accuracy. So that is another measure that we can use for evaluating. So you can use accuracy and the loss to see how best the model is working well. So then the accuracy of classification is highly influenced by the distribution and diversity of data. The goal is to build machines that can learn from the data and to increase the accuracy of the output. Train train machines train machines with data to perform specific tasks and deliver accurate results. And it uses self-learning algorithm to produce predictive models. So now what do you understand from all these things? Number one, we have to have very good, or even if not very good, basic understanding about statistics, probability, and optimization techniques. The number two, you have to be very careful in selecting one machine learning algorithm out of the available array of choices, and you will be able to come to a conclusion whether the model is performing well or not with respect to its performance, right? So there is no assurance that the model that works well for heart disease is well suited for cancer detection or vice versa. So depending upon the data, the model is getting trained and then it gives the accuracy. So out of the available choices, we must be able to choose the one that gives the best results for our data. That is second aspect. Third aspect is now the model that when used for training, it understands the data, it produces the pattern, and then it goes for producing the result. Then the accuracy of classification, that is the accuracy that we calculate, happens to be highly influential by your variety of data. Then when you build a model, you have to ensure that the accuracy should keep increasing as you work with more and more number of data. Okay. So how machine learning works? It can work on a decision process. In general, machine learning algorithms are used to make prediction or classification based on some input data, which can be labeled or unlabeled. If you're able to follow me, your algorithm will produce an estimate about the pattern in the data. See, now when we apply the machine learning model, it learns the entire pattern and then it comes out with one output. That output can be identification of disease, identification of an object, identification of a person, then identification of gender, and it can be anything. So then it uses an error function. An error function evaluates the prediction of the model, and if there are known examples, then the error function can make comparison with the other set of metrics to assess the accuracy of the model. Right? This is as we do for any kind of experiment, right? There should be some metric with which we control whether it is right or not. So the model optimization process, if the model can fit better to the data points in the training set, then weights are adjusted to reduce the discrepancy between the known example and the model estimate. The algorithm will repeat this process, updating weights until threshold of accuracy has been met. So don't worry about all these things. Each of this process is done in a single line statement. If it is optimization, there is single line. If it is accuracy computation, it's a single line. If it is error computation, it's a single line. So now it's very interesting to, I think you must have seen in a slide which came probably some 4 or 5 slides above. One aspect is the mathematical aspect, other aspect is programming. So now we are talking about the programming aspect. So now there are different types of variations. One is supervised learning, unsupervised, then semi-supervised and reinforcement learning. What they talk about supervised? Data scientists provide input and output. Underline this. For supervised learning, we need both input and output. And there should be a feedback to build a model. When you're building a model, it is not sufficient just to have input and output. The input should be taken, the output of one stage should be taken as the input for the next stage and so on. Then example algorithms, linear regression, like this is going to find place in sales forecasting, risk assessment. Then support vector machine. This is used for image classification. Then financial performance comparison, decision tree. This is used for predictive analytics as well as pricing and many other applications. The next one is unsupervised learning. In this case, we give both input and output. But in the case of unsupervised learning, we are not going to give any kind of input as any kind of output as such. It is going to work only on the input. In the case of supervised learning, it finds mapping function between input and output. In the case of unsupervised learning, it forms mapping function to group the similar objects and then remove the dissimilar ones. So, example algorithm, sales function, word association, then searchers, then k-means algorithm or k-means clustering. It involves performance monitoring, then searcher intent, whatever that we want to search for, that's decided by the k value. Then the next one is ANN. This is very, very important. Whatever be the type of problem that you're going to solve, please ensure that you work on the given problem, which can be categorized into either supervised or unsupervised or semi-supervised or reinforcement learning. So now, though I told you the coding aspect is very simple, but taking a decision about selection of the model and generalizing the model is very, very challenging. So in which you have to pay a week's attention and try to see which model is best suitable for which problem, or which problem can be solved by which model, and what are the performance metrics, what is their level of performance. All these things are to be ascertained. You have to take a note of everything. And then, as we have seen, the example algorithms are unsupervised, sales function, word association, searcher, and K means clustering can perform performance monitoring. It searches the internet. Then ANN generate new synthetic data, and data mining and pattern recognition becomes an inherited component. Then the next one is semi-supervised learning. In the case of semi-supervised learning, it's kind of a middle point between supervised and unsupervised. Builds a model through a mix of labeled and unlabeled data, and that will lead to a set of categories, suggestions, and example labels. That's what you call as labeling. Unlabeled means it has only the independent value. So that means that we have to decide that we don't want to produce anything as output, but still I want to group them. Then we can make use of this. The next one is like we come again. This example is generative adversarial network, audio, video manipulation, data creation, then self-trained naive-based classifier, natural language processing, and so on. And then reinforcement learning. I think from the name you can understand. We try to reinforce again and again on the performance of the model. If the model is performing well, then just call it as the model is performing well, then you give a component called reward. And if the model is not performing well, you give a component called penalty. So as it toggles between penalty and reward, it is able to adjust. As we teach a lesson to the child and then we ask it to recite, wherever it is stuck, you give a pat, or when the child is reciting well, you just clap your hands and say that you are doing well. In the similar way, when the model is working well, then we give a reward. When the model is not working well, then we give a penalty. It goes accordingly. Right? So supervised learning, let me explain with an example. So by looking into this, you'll be able to have better understanding about this supervised learning. So you have got known data, known response. What is known data? You have got set of what do you call as records, right? In the record, when I have both input and output, then I told you it is a labeled data set, which is very important to work with. The first one that you call a supervised learning model, right? So what we do is we train the model with known data. Response is the output. We train it with the input value as well as output value. So now what happens? The model is able to understand. And after that, this model is being developed. Now we take the model and we give the new data. Now with this model and new data, we are able to predict the response. That is, um, this is taken as dog, and when the model is able to predict the object well, it is 100%. Now, when it is not able to predict well, then accordingly we have to go for fine tuning the model. Okay. So now this says that to classification and categorical output regression and continuous output. So now this is a dog, this is a cat, this is a dog, this is a robot. If it is able to distinguish, then it will be interesting. So then now types of machine learning. There are two major types. One is regression, other one is classification. So what is regression? We regress on the given data. For the given set of data, it must be able to produce the result. We already know this is an example for fitting a straight line across the given set of data. So the simplest approach is using linear regression. So mapping function is used to map the input and the output data. Then the second one is continuous output, because here the data is not distinct, because you could see there's a straight line that is flowing across it. So what do you mean by the principle of fitting a straight line? The line that you formulate using your equation must be able to cover as many points as possible. Right? If that is the case, then the line is a better line. If that is going to just touch upon only the minor set of data points, not the original set, then it is called as, it is not a good straight line to fit with respect to the given problem. Okay. So nature is ordered, metrics is we can measure by using accuracy, error value, algorithm is linear regression. So now here there is a mail, you can understand. Well, you have got input, you have got the output. So for the given input, we must be able to predict the output. This is the best example. And here the problem is solved. Now in the case of new problem, we must be able to solve it by going for x-axis data and y-axis data, predict what is z-axis data. Whereas the problem is totally different here. You have an email, right? You have a mail um, to be um, uh, to be classified as whether the mail is a safe email or not, right? So what happens? The mail with the metadata, whoever be the creator of the image or whatever be the essential facts that are present along with this data that is taken, along with that we give it to the machine learning model. Now it will be able to decide whether it should be moved to the spam folder or to the new folder, not a spam. Accordingly, it should be there. So, are you able to hope it is making sense? Excuse me.
Yes, ma'am. Ma'am, few,
Is it
uh,
is all fine up to this point?
yes, ma'am, it's not an issue.
Okay, thank you. Now, this is an example for reinforcement learning. This is like the girl is training this dog, and there are a set of actions. Then it is eating. It has to react. It has to get trained, and whenever it is good enough, when the performance is good, when it reaches the um, maximum expected outcome, right? A reward is given. And then when it is not doing well, you give the penalty, and accordingly it works. So now, as you see this slide, this box, we give the input data. You could see here there are red, violet, and green dots. Now they are to be divided. So now when this is sent to a model, the model will be able to get categorized. The model will be able to categorize the given input data. As you could see here, all the red clustered together, green clustered together, and violet clustered together, right? So this diagram explains how the input is being taken and how it is processed and how we are able to produce the output with respect to reinforcement learning. So as you see the general machine learning process, we start with defining the objective, right? Define the measurable and quantifiable goal for the given problem. Use the stage to learn about the problem. Then data preparation, it involves normalization, transformation, missing value, and the outliers. So the computer science faculty will be having good knowledge about this data science, data preparation. Then suppose if there is a missing value, we have to replace it. If there is a duplication, we have to remove. And if there is an outlier, what is an outlier? When you have a data set, the records which are not falling closer to the input data, that is with respect to its property, and they are called as outliers. That is, we can call them as extraordinary or unwanted data. That is outlier. Then you have the transformation. Okay. So study model accurately work better than the naive approach or previous system. Here, I'm just reading this. So we started with this. You could see here, now this is cyclic process. There is no hard and fast rule that I have to follow a systematic way and then do it. So for easy understanding, they have given this, but however, as you take the model, everything is taken care by itself. It takes care of a building based upon the corrections, variations that we give, and then we evaluate the model and it just goes on. So the normalization, transformation, missing value, outliers are being handled. Then data splitting, feature engineering, estimating performance, evaluation model selection, evaluation model selection, all are being given. So now this model building is about selecting one best model and making the model to solve the problem. Then we evaluate the model, and the model is performing well here, and the evaluation fails. Then we have to start from the first one. And after that model deployment, we can deploy it for for other use. That is a future use, it becomes possible, and we have it. So define object is data preparation, model building, model evaluation, model deployment. Again, go for defining the objectives. It becomes IP. So this steps of machine learning process: step 1, data collection; step 2, data preparation; step 3, choosing a model; step 4, training; step 5, evaluation; step 6, parameter tuning; and step 7, prediction. So you have to follow only this step. And then what do you mean by, now we have discussed about the various models, right? We can have linear regression, then multinomial regression, logistic regression, then support vector machine, um, then A-based classifier. They have all these kind of models, but it is equally important to decide about the data set, right, that you are going to deal with when you have to train the model, or when you are uh, going to solve a problem using artificial intelligence. The first step in developing a machine learning model is training and validation. But now that is done by means of partitioning the data set. Now, what do you understand by partitioning the data set? When I have 100 records in a data set, instead of using all the 100 records for training, what I would do is I will take only 60% of the data set that will be used for training. Then after I finish training, I take the next 20% and then use it for validation. After training and validation, I can go for testing, right? So this is called as data splitting. The data splitting a percentage can be of anything. When you have very large amount of data, accordingly you can make predictions. Okay. So training set sample of data used to fit the model. It uncovers or learns relationship between the favorites and the target variable. So what are the favorite features? When I have 10 input parameters, then the values of those 10 parameters are called as the values on which the model is going to be trained. So when I have 10 input variables, those 10 input variables are being called as features of a given data set, right? However, when you have more number of input parameters, that will complicate the process of constructing a model. Hope you are getting the point. As you have more number of data, then training is better, prediction is better, accuracy is higher. But when you have multiple number of records of data, that makes the process probably easier to handle, and hence it is very important to divide the data set into 3 partitions: training set, validation test, and then testing set. There's no change in this. But however, why do we have to have these 3 variations? Can't we just manage with a single one? Whenever there is a training, there should be some test, right? So test is done in 2 flavors. One is validation, other one is testing set. The sample of data used to fit the model is called as training set. It uncovers or learns relationship between the features and the target variable. I want to come back to this point again. When I have 100 such features, when I have 100 such input variables, I cannot build a model with all the 100. However, I can go for another interesting area called feature extraction, or it is called as feature selection or feature engineering. So what do we do in this case? We try to see which of the attributes among the 100 are highly important, highly significant. Probably out of 100, I may take, out of 100, I may be able to manage only with 25 features. Please remember, feature refers to input parameters, right? Instead of having 100 input parameters, I'll be able to arrive better results with just 25 parameters. What do you mean by that? This clearly shows that when you have multiple features, that may inhibit the process of your um, training the model. So you have to keep them as minimum as possible. That is done with the support of feature engineering. So it uncovers or learns relationship between the features and the target variables. So validation set, the sample of the data used to provide an unbiased evaluation of the model fit on the training data set while turning the model by that is by means of one process. Underline this. This is called as hyperparameter tuning, right? That is um, in the first point in validation testing. Now, this says that when I have, please remember the input variables of the data set are called as independent parameter. I made a mention in the very beginning, every model will have its own set of parameters, and those parameters are being called as hyperparameter. Once the model's definition, once the model handling is very simple, very easy to understand, then we go for validation, wherein we try to fine tune the hyperparameters. Please remember, when I talk about hyperparameters, when I talk about linear regression, I may have 2 or 3 parameters. Those are the hyperparameters of linear regression model. When I take, say, decision tree is the one which will have multiple set of hyperparameters, like how many leaves and what is the depth of the tree, like this. Like this, I can have SPM, I can have Bayesian classifier, and many such things. So it's very interesting to note that first one deals with reducing the number of features of the data set. Second one, validation, that deals with shall we fine tune the model, like 0.01 be the scale in which you just go for fine tuning. So what is fine tuning? We try to find the best optimal value for the hyperparameters. Suppose if we have how many number of leaves in the decision tree, we decide on it. Okay, so tuning model hyperparameter deals with how best you can fine tune the hyperparameters. Remember, hyperparameters are exclusive for each and every model. They are not at all overlapping. So it is used to find how accurately it identifies relationship between the known output of the target values and unknown and known a set of target variables and the data sets other features, right? So we just try to establish how best you can have correlation between the input parameters and output parameters, how best you can go for fine tuning the hyperparameters. So what is testing? So far we gave the input and output and trained. Now in the case of testing, you just give the input. The input should understand the given input value, and then you have to go for testing, right? What you do in testing, the sample of data used to provide an unbiased evaluation of the final model fit on the training data set, right? It is having some knowledge about training and the corresponding data set. So then it provides a final estimate of the model performance after validated. So you can see here, it is very interesting to see. Now we have to decide in what ratio am I going to split the data, whether it is 60-40 or 70-30 or 75-25 or 80-20 or 90-10. That should be decided by the programmer by trial and error. There is no hard and fast rule that it should be 60% and 40% and 80% and 20%. No, right? So we have to go for trial and error method and see which is the best split. Now, when we talk about this kind of machine learning model, we just come across 3 major techniques that's known as underfit model, overfit model, and good fit model. Before we go to the definition, let us see this curve fitting, and then we made a mention about fitting the straight line, right? Something like that. So we just draw this line. There should be as many number of items we present. So now there are many number of points which are falling away from this line. So this is not a good fit. The second one is it is able to like divide the images, the bullet points and the intermark into two categories with the minimum comparison. Then third one is called as overfitting. See now there is, please try to understand. I have got these kind of into and then circle when you draw the line, and then whatever that you get as two divisions, right? Like two group of data. In that data, it can have two different approaches. One is accurate classification, other one is misclassification. Now, when you go for grouping, when one cluster contains one or more another cluster, this is like mixing say rice and small uh, kind of stones, or mixing with pebbles. So now when you want to go for better classification, you have to have one group separately, another group separately, without any overlapping. But in the case of second, we are able to have good compromise. This is like it is unrealistic. Not even single item is misclassified. All bubbles this side and all into marks on the other side. So using this kind of these models and boost, you can see here this the performance of this, like model complexity and error is taken into consideration. This is how it goes. As we do the kind of increasing the model, then accuracy increases, and then it progresses after some time. So then you have to find the optimal value for that. In the case of this best fit, you can see here, right? This is called as best fit. So this is the line that decides about the best fit. Up to this point, this works well, and beyond this point, you see here error increases. Here training error decreases. See now you have to make them balance. The error of the test and error of the training should be almost similar, right? So there are a lot of metrics that are used for measuring the performance. One is classification accuracy, and these are all formulas, and you can just like that deploy it in the model. It will be able to calculate what is accuracy. If there are total number of predictions, right, you take it in this point, and the total number of predictions and total number of correct predictions are being taken. When I have 1,000 records, as I made a mention earlier, 10 is to 8. So out of 1,000 records, I'm able to predict 83, 830 records correctly. Then what is numerator? Numerator is 830. Denominator is 1,000. So 130 divided by 1,000 is equal to, um, 830. 830 divided by 1,000 is equal to 83% accuracy. Now it is 900 by 1,000 means 90% accuracy. 950 by 1,000 means 95% accuracy, like this. So this is the most common metric that we use. Then the second one is called as confusion matrix. Confusion matrix is also very important when you really want to get into machine learning. Now, I told you, suppose if I design a model for disease identification, whatever, suppose all the cancer cases are being called as positive, and all non-cancer will be termed as negative. That is, no cancer is present, so it's negative. Now, with respect to this, you have got two major things. Just see this. This is true positive, true negative. So the true positive are the one which are having disease and correctly identified as disease. Hope you are able to get. So all the diseases which are present are identified correctly. Then the next one is all the negative points which are connected, right, which are collected through the process of the model, which are identified as wrong, right? Disease is identified as disease, and no disease is identified as no disease. So this is what you mean. We'll see here. Accuracy is the proportion of total number of predictions that we will connect, and then positive prediction value precisions. It is the proportion of positive cases that are correctly identified. Negative predictive value is the proportion of positive cases that they correctly identified, right? And then negative prediction value, the proportion of the negative cases that were commonly identified, and sensitivity, specificity, recall, F1 score, you'll be able to sail through with this very easily, right? No problem at all. So libraries and packages that use for machine learning, you can use NumPy, you can use Matplotlib, you can use Pandas, you can use Learn, right? Scikit-learn, all are very simple examples. So what do you understand from this? To understand machine learning, you need to have basic knowledge of Python programming. Then, in addition, there should be a number of others. NumPy and all other packages have got a lot of libraries, predefined libraries. NumPy, this is used for n-dimensional array object. Panda, it is used for data analysis. By loading the data in the data frame, we'll be able to work it. Then Matplotlib, it is 2D plotting library for creating graphs and plots for visualization. Then scikit-learn, this is a algorithm that is used for data analysis and data mining activities. Then Seaborn, data visualization, library based on the Matplotlib, right? So these are all the kind of packages that we can use. Then application of machine learning. See, as I told you in the beginning, the number of applications are countless. Healthcare, language translation, fraud detection, customer support, then email spam identification, then social media service like face recognition, identification of similar pins. Right. So now let me just go through other applications like customer support, email spam, malware setting, social media service like Facebook, similar pins, then virtual personal assistant, smarter speakers, smarter phone, mobile phones, then prediction while commuting. When you are traveling, you'll be able to see when you travel in Bangalore, in the peak hours, we will be able to gauge what is the traffic before you could go to the place through Google Map. So that is also another one, traffic prediction, online transportation network. These are all the examples. You can see here, now we are moving on to deep learning. Deep learning is a branch of machine learning that comes under artificial intelligence. It is called as deep learning. It has got a mechanism provision to learn the objects in a deeper manner than the machine learning. So always the results of this will be better. Okay. So this uses learning algorithm to extract deeper patterns out of the data, uses hierarchy of multiple layers and mimicking BNN. It's capable of voluminous data for better learning. Then deep learning is an AI function that mimics the functionality of human brain, and then as the brain processes, the model is able to process the data. It is able to process data for the purpose of decision making. So deep learning AI is able to learn from the data that is both unstructured as well as unlabeled. Underline this. In the case of that, it should be ordered set of data, but this deep learning can work on ordered or unstructured set of data. Then deep learning is an AI function that mimics the functionality of human brain in processing data for the use of decision making. Then deep learning AI used to learn from data that is both unstructured and unlabeled. Underline all these things. Deep learning has offered noteworthy capabilities and advances in voice recognition, image compression, self-driving car, natural language processing, and many more. And so this is how the deep learning works. Deep learning applies to a multi-layer process, learning from rich hierarchical features. So now in the previous case, if we have blood pressure of a person, then sugar reading in fasting, sugar reading in postprandial, it is all fixed. But in the case of this 3D modeling, right? Or in the case of designing or identification of an object, designing an object. Now here we can see this image. Um, a small portion of this image is being taken, and then we try to learn the low features as we just transform it into a bit representation in image. Then this has got low level features. Then this is called as mid level feature. This is called as high level feature. So by combining all these things, it will be able to make predictions. So now let us see, we take the pixels, then we identify the edges, find the object, and then you just recognize the object model. The same thing is being given. Then before we go to the quantum computing and AI, let me just touch upon neural network. Neural network has got three major layers: input layer, hidden layer, and output layer. Now this ANN is the most powerful tool. This AI will be, I mean, ANN will be able to solve any given problem with the highest accuracy with better complexity. So that network is divided into three components: input layer, hidden layer, and the output layer. So what do we do with respect to this? Data provides each node with the information in the form of input. The node multiplies the input with random weight, calculates them, and adds a bias. Finally, nonlinear function, also known as activation function, or apply to determine which neuron is firing. I think you all must be knowing about that will be two dendrites that then they just fire, and that is understood as a signal to learn something new or to understand something or to converse with the person. So ANN, just see this. This is the input layer. You assign weights to this. Then this is summation. We find the summation, and then we just pass it on. That leads to the next stage. After that, we find the output. Output is taken whether it is cat or dog. If this is the image which is given, you can see here input layer. This is another layer, summation layer. This is what do you call as activation function, and the last one is output. Then when we talk about deep learning, necessarily we have to talk about CNN. This stands for convolutional neural network. This is extraordinarily good in handling images. If you have 10 image, you have XRD image, then you'll be able to analyze with multiple number of parameters with multiple number of layers. So this is the input. The small input portion is being taken, and that is going to be manipulated with respect to different filters. You call filters or kernel, or you can call it as window, whatever it is. So what is convolution operation? It is as simple as point-wise multiplication. Um, when I have a what do you call this, a window or a kernel of same size, I take the first pixel, I correct it. I take the second pixel, multiply the second pixel in the convolution neural network. Then after you finish this kind of operation, convolution operation, then the extracted features will be transformed into a kind of um, one-dimensional array, and that is being taken. Right, this is one-dimensional array, and then the one-dimensional array features are fed into the model as in a fully connected model. So you can see very easily input is given, convolution operation done. So the colorful ones are being called as fully connected layer, input, output. Input layer, output layer, the both in the blue, and in the red are hidden layer. So this is first hidden layer, this is the next hidden layer, right? You have to. So how does CNN work? CNN, the components of CNN are, see, convolutional layer. This is the convolutional layer. Then it uses a rectified linear unit, ReLU. Then pooling layer, fully connected layer. You can see here, we take the image, we extract the features. What is the purpose of working with the CNN? Now with this bird, I'm going to verify whether the given image is a bird or not. For this purpose, to understand how a bird looks like, we take the image, try to extract the features, wings, legs, then eyes, nose, etc. And instead of taking the entire image, what we do is we take only the features. This is how we do, right? When you look at a person, you have a brief image of with these eyes, with these nose, with this nose and with this eyebrow, with this face cut. Then that person should be identified as so and so. In the similar way, instead of meddling with the entire image, the convolutional neural network will extract the important features, and those important features will become input to this fully connected layer. Otherwise, this will have 1 million times of data, and that cannot be modified, that cannot be used. So you take it, it is converted into a one-dimensional array, right? And that array is made as a single, that is made as, this is your input. You have done convolution operation with respect to blue and yellow. And then you have got minimized features, and minimized features are fed as input. Then it is processed, you get the output. So you have convolution layer. Then you have got this rectified linear unit. This is too early for those who are not aware of this artificial intelligence. However, I just give an example. Now, when you have the intermediate results, which are not discretable, which are not specific to the problem with which we are working, we apply some threshold value and try to transform them between 0 and 1. That process is called as applying rectified linear unit. Then the next one is pooling layer. The purpose of pooling layer is to identify the maximum number of good features. So that is done. So the rectified feature map next feeds into the pooling layer. Pooling is a downsampling operation that converts. You can see here, we can read it. Pooling is the downsample. What is downsample? When I have say 7 cross 7. 7 cross 7 means how many points will be there? 35 points will be there. Out of 7 cross 7, probably I reconstruct 3 cross 3 feature map or 5 cross 3 feature map. So what does it mean? That means that I want to extract the features based on the degree of the window, degree of the kernel. So I take all the features, I minimize the feature, and then what I do is I converted all the extracted features as single fully connected. It just goes on, then you get. So pooling layer is meant for dimensionality reduction. Convolutional layer is meant for feature selection. Then fully connected layer is meant for working on the data and producing the result. Then the next one is deep learning model, CNN image classification model. It is input image, apply the feature map, then using rectify function that we have already seen. Then max pooling, filter, flattening of the feature, and then fully connected layer, you get it, right? See, as you keep working, you'll be able to understand it better. When you just read the basics and theoretical aspect, it looks a little fuzzy. But when you start applying, it is very simple. So deep learning applications, you can use it for image recognition, NLP, natural language processing, then portfolio management and prediction of stock price movement, then drug discovery, especially if you are in chemistry or if you're interested in biological genomic sequencing, then you can work on this. Drug discovery, better diagnosis of diseases in the healthcare data set, then speech recognition, and then robots and self-driving cars. So these are all some illustrations. So challenges, it's all the deep learning models are data hungry in nature. You need large volume of data for training. So at times we may not have such a large volume of data in reality. Then it is computationally intensive. When you compare the degree of computation, deep learning is computationally complex than the other one. And autoencoders are the one that you use for various applications. Like you can use it for denoising, or you can use it for image compression, data compression, etc. Then easily fooled by adversarial. This is yet another world of artificial intelligence that is called the generative artificial intelligence. That is generative adversarial network. This is yet another new domain. Probably computer science faculty can have one session on generative artificial intelligence. So now the new era is working on GAN, or learning about generative artificial intelligence. This generative artificial intelligence is evolving on par with quantum AI. Then it's poor at representing uncertainty. When the size is very small, the model may not work well. Then uninterpretable block sizes. We do not know how it is working. Then there will be lesser scope for us to modify and make it perfect. Then it is finicky to optimize. Non-convex, right? And the choice of architecture learning parameters also since design the new one, right? So transfer learning, this is yet another one. I'll just touch it upon. So far we have come across machine learning, deep learning. This is you take a model and then you fine tune it on your own. But interestingly, in the domain of artificial intelligence, researchers have come out with a pre-trained model. They are called the transfer learning model. They must have trained the model voraciously to the greatest extent possible with the support of very large data set. So they must have acquired that learning aptitude in each of the model. But when I develop a model for disease identification, heart disease identification, that model can be used for lung cancer identification. This is as simple as that. So what do we do? The training knowledge you got on heart disease has been transferred to lung cancer identification. So transferring the knowledge of one model to perform a new task is called as transfer learning. Transfer learning is the improvement of learning in a new task through a transfer of knowledge of related tasks that has already been learned, right? So on the model it has learned, then we try to apply the result and try to get it. So then the reuse of pre-trained model on new problem is known as transfer learning in machine learning, right? A machine uses the knowledge learned from the prior assignment to increase the prediction about the new task. New task in the process of transfer learning. So I just want you to understand this is another way of problem solving. There are a lot of transfer learning models available like GoogleNet, AlexNet, Inceptron, right, ImageNet, SegNet. There are a lot of pre-trained models available, and you can also try whether the model is performing well or not on your problem. If it is working well, again, that's a scope for you to fine-tune the performance by altering various values of the parameters and the like. So it's a deep learning methods are data hungry. Already we have seen more than 50K data items are required for training. And then the distribution of source and target data must be the same. The labeled data in the target domain may be limited. Then a lot of data time resource needed to train and tune neural network from the scratch. Right? Suppose when you develop one from the beginning, it is time consuming. It eats up your time. But whereas when you do it from transfer learning model, already it has got trained, so the process is easier. An ImageNet deep neural network can can take weeks to train and fine tune from the scratch. So it is like more like if you want to eat cake, right? One option is take the cake and then do the icing, write your happy birthday to so and so, and then do it. Another method is take the flour and take your sugar, take butter, do it everything by yourself and then write it. So transfer learning is taking the crust and then writing on the wall and then do it. And the other one is you start from the scratch and do it. So unless you have 256 GPU, graphical processing unit, right? It is possible to achieve in 1 hour. And that is the process of getting the result. So cheaper, faster way of adapting neural network by exploring their generalized properties. So these problems are typically addressed using the principle of transfer learning. Traditional versus transfer learning. Then learning process of traditional machine learning, you can see you have a learning system, different tasks, it is circle and then triangle and then diamond. It's happening, then source task and target task. In the case of transfer learning, already you got trained on this, that is going to be applied, that is going to be used for doing the final result. So types inductive, transductive, and unsupervised. Let's not worry much about it because as you keep learning, you'll be able to understand. Let's keep this also for time being because unless you are strong in it, it's very difficult to follow it. Now, benefits of transfer learning, I tell it boosts productivity, it increases accuracy, and the risk reduction is a more improves learning process. So for this advantages, we normally go for doing it. Popular pre-trained models are AlexNet, BTG, GoogleNet, ResNet, then SqueezeNet, another version of Next. This is ResNet, then DenseNet, ShuffleNet, then MobileNet. So a few examples. Then the year in which they have introduced are also. Now quickly we'll go through this quantum AI. So quantum AI is the emergence in the field that combines quantum computing with artificial intelligence to potentially revolutionize the problem solving, right? Data processing and algorithm design. So by leveraging quantum mechanics, quantum AI aims to perform tasks that are infeasible for traditional classical computers. Please try to understand when the problem cannot be solved by traditional computing, that's a scope uh, for, for quantum computing to come for a rescue. So by leveraging quantum mechanics, quantum AI aims to perform tasks that are infeasible to traditional classic computers, especially in the area like optimization, machine learning, and complex solutions. Quantum computers use, in the case of digital computers, we use just bits. In the case of quantum computing, we use called as qubit, QU for quantum bits, instead of classical bits, allowing them to perform multiple calculations simultaneously. This is the keyword. This enhances the speed and efficiency of AI algorithm, enabling them to process massive amount of data at unprecedented speed. Okay, the ultimate aim is it is faster in nature. It is able to solve the problem which cannot be handled by traditional models and classical models. So qubit versus classical bit. Classical bit has got two states. It is either 0 or 1. In the case of qubit, can exist in the state of both 1 and 0 simultaneously due to the position called superpositioning. So there is another aspect called entanglement. Qubits can become linked so that the state of one instantly influences the state of another even on large large distances. Hope you are able to understand. See now classical bit can exist in any one of the states 0 and 1. In the case of qubit, it can exist in 0 and 1 simultaneously. Now, because it is able to be there at different positions, that helps us to have better computation, which can influence the entire process of computation. As we have logic gates in traditional computing, we also have quantum gates. Just as classical computers use logic gates, quantum computers use quantum gates like Hadamard, PolyX to manipulate the qubits because we have to work on qubits. So quantum gates enable computers to perform multiple or complex computations through quantum circuits. So let us have a kind of comparison, classical computing and quantum computing. The basic operating unit is bit, it is either 0 or 1. Qubit is, it involves 0 as well as 1. So information density, n bit storage falls one value. Value can be of form 0 to 2 to the power n minus 1. If I have 3 bits, then I can store 8 values 0 to 7. Here, Qn bit can hold, just see this 2 to the power n values, the complex coefficient describing the state. So see the way in which it is increasing. Then information transformation, Boolean logic operations, quantum gate operations on energy state manipulation. Then noise tolerance, minimal noise tolerance. Quantum circuits are extremely sensitive to noise. When the noise is more, then quantum computing may not work better. Then copy operations, no restrictions on copying. Whereas here, copying quantum information destroys the quantum state. Because here it is discrete, where in the case of quantum computing, it is superposition. So copying is not possible in the case of quantum computing, whereas it is possible in traditional computing. Error correction, easy and scalable error correction. Quantum circuits may run many times to converge on a result. So this will be time consuming. So this diagram will be able to make you understand the classical computers bit and quantum computers qubit. So now if this is head and this is tail. So head means 1, tail means 0. Okay. So here this is only head, only tail, only head like this. When this is tail, then all of them are tail. When you just compare them, it is, this is not neither head nor tail. It is between head and tail. So this is called as 1 plus 0 because this part represents 0 and this part represents 1. So you are going to have multiple orientations of this qubit, 1 plus 0, 1 plus 0, 1 plus 0, 1 plus 0, 1 plus 0. Like this, you can go for any number of combinations. So states in between head and tail are possible in the case of quantum computing. Applications, we can use it for optimization problem, like quantum AI can tackle combinational problems like supply chain optimization, portfolio management, logistic planning, potentially funding solutions, then faster and in a better, effective way. Then machine learning, quantum algorithms can process large data set complex models with reduced computational requirements, enabling faster training and the execution of AI models. So drug discovery and material science, this is how we have to make all the multidisciplines to come together. So quantum AI can simulate molecular structure aligning in drug discovery and new material creation. Cryptography, quantum computing challenges traditional cryptography, but also enables quantum safe encryption methods, right? You can use it for encryption also. Then NLP, speeding up tasks like language translation, sentiment analysis with quantum enhanced machine learning models. So prerequisite for AI, the basic prerequisites that will help to get started with AI, a strong hold in mathematics, namely calculus, statistics, and probability, a good amount of experience in programming like Java, Python, a strong hold in understanding and writing the algorithms for quantum bit and quantum AI computing, good amount of knowledge in discrete mathematics. The will to learn machine learning is very, very important. I mean, machine learning languages, machine learning models, quantum AI models. This is the last one, but the most important one. So Google CEO Sundar Pichai says, in the long run, we are evolving in computing from a mobile first to an AI first world. That is what we are looking ahead, looking for. So I've collected all the details from web resources. I'll be happy to answer any queries related to this. So the conclusion that I want to draw from this entire presentation is that there is new era of computing that is evolving that you call as quantum computing. As this is one of the promising domain, the researchers are coming out with combining AI technology with quantum computing that is called as quantum AI. So this quantum AI has got a lot of scope. As you could see, I think, did I miss? I think there is one called, once again. Please hold on.
Good evening, ma'am.
Yeah, I missed this one. I don't know how I missed this. Now, this quantum algorithms in AI. Now, we talked about neural network. We talked about SVM, and now, can you see the slide? Hello.
Yes, ma'am. Yes, ma'am.
Good evening. Can you see the slide that I'm showing?
Yes, ma'am. It's showing.
Hello.
Yes, ma'am. It's showing.
Hello. Sir, can you see the slide?
Yes, ma'am.
Hello.
Ma'am, yes, ma'am. It's showing, ma'am. Hello.
This mimics neural network layer, but with the quantum operation to enhance pattern recognition image processing. Yes, okay, thank you. I just want to show you few. Yes, okay, I'm just continuing. So then there is another one called support. Can you hear me? Am I audible?
Yes, ma'am, you're audible, ma'am.
Hello.
Ma'am, yes, you're audible. ma'am.
Hello.
Yes, ma'am. You are audible, ma'am.
Thank you. As a once okay. So now we have. Thank you. Thank you. Then we have got quantum support vector machine used for classification and clustering with the help of quantum computing. Then quantum annealing is another approach specialized for optimization problem, helping to find best solutions faster than classical annealing method. And what is the significance of all these methods? These algorithms can reduce the computational time for AI tasks like training the model, pattern recognition, decision making. This is the new era that is evolving. As you have rightly coined the title for your FDP, quantum computing, the next generation of computing, whatever it is. So now this is going to give new perspective on optimization problem, machine learning, drug discovery, material science, cryptography, natural language processing. So these kind of applications are going to get enhanced with the support of quantum computing. So this is going to be a kind of new model, new approach, which is totally different from traditional computing as well as machine learning. So you are evolving to a better standard wherein we take the benefits of quantum computing combined with machine learning, or probably later you'll be having deep learning also. So the takeaway point is the new generation of researchers are going to work with quantum AI rather than working with AI models. That is the understanding.
Sukumar,
That is the
proceed.
understanding, right? So I'm done with my presentation. I'll be happy to take questions. Hello.
Hello. Ma'am, good evening, ma'am.
Good evening.
Ma'am, very good presentation, ma'am. We learned the concepts, very innovative step. So we all like, ma'am. Ma'am, my question, suppose in my, I'm trying the data, so my model is trained once. Then suppose the model have overfitting or underfitting, what can I do, ma'am? Then
See, if it is overfitting,
additionally, I have one question now. Suppose how to avoid the underfit and overfit, ma'am? I have two questions.
that should be done with respect to you have to increase the size of your data set, and you have to change the proportion of your data set. See, when training accuracy is there, then testing accuracy is there. So when it is performing well in the training accuracy, when it is not performing well with respect to testing accuracy, that means your model is not able to learn properly from the data set that you get, right? So what do you have to do? You have to increase the data set. Suppose if you have 100, you have to make it as 500. And you must be able to increase the variability of your data set. And then you must be able to fine tune the parameters.
Okay, ma'am. So any steps to avoid this underfitting and overfitting?
Actually, this is how we have to check whether the model is working well or not. There is no chance of, like, at times when your data set is perfect enough, then you may not land up in overfitting or underfitting at all. So what is overfitting? The model is not learning the idea, rather than it learns the pattern by itself. Suppose if hello, if you teach your child, you have to understand 1 multiplied by 2 is 2, 2 multiplied by 2 is 4. That means
Ma'am, thank you, ma'am. Thank you, ma'am. Thank you.
Hello, Said Ali.
hello.
Hello, Said Ali.
Yes. See, when you have the model, at times, the model need not suffer from overfitting or underfitting at all.
Said Ali, you can ask a question. Dear participants, if you have any doubts, please raise your hand. I will unmute your mic, then you can ask a question. Uh, if there is no any questions, we will conclude the session. Okay. Thank you so much, ma'am. This is a wonderful sessions. Now we are going to conclude these sessions. I would like to invite Bhuvaneshwari ma'am, Assistant Professor in Physics, to deliver the vote of thanks.
Sir, my voice is audible, sir.
Yes, ma'am. You are audible.
Good afternoon to everyone. It is my honor to deliver the vote of thanks as we conclude this engaging and thoughtful-provoking online faculty development program on quantum computing for the next generation, organized collaboratively by the Department of Physics and Computer Science under the DPT Star College scheme. First and foremost, I would like to extend our deepest gratitude to our distinguished speaker and resource person of today's session, Dr. P. Sanmugha Madhu ma'am, your expertise in the field of AI, ML, and deep learning has significantly enriched our understanding of this cutting edge technology. Your insightful and thought provoking sessions have inspired us to delve deeper into this fascinating and rapidly evolving the field. We are truly grateful for the time and effort you dedicated to sharing your knowledge with us, ma'am. I hope everyone gained more knowledge about today's session. Once again, thank you, ma'am, for the clear PPT explanation with real-time application for us. Thank you, ma'am. I would also like to express my heartfelt thanks to our institution leadership, our Dr. R. Manikam, CEO and Secretary, Dr. S. Balasubramanian, Principal, Dr. S. N. Suresh, Vice Principal, and Dr. KPV Sabaris, Dean and Research and Development. Your continuous encouragement and support have been instrumental in making this FTP possible. Thank you for fostering an environment that encourage academic growth and innovation. A heartfelt thanks to go to the heads of the organizing department, Ms. D. Uma Maheshwari, Department of Physics, Dr. S. Raja, and Dr. T. Velumani, Department of Computer Science, your visionary leadership along with the supports. I would like to thank both the department faculty members who have played a key role in making this program is the successful way. I would like to express our deepest gratitude to all the student participants for your active involvement and engagement throughout this program. Your enthusiasm, insightful questions, and thoughtful contributions have greatly enriched our collective learning experience. We hope you leave these sessions with a deeper understanding of artificial intelligence, machine learning, and deep learning, and we encourage you to continue exploring this fascinating field and further. Thank you once again to everyone who has contributed to this program, speakers, organizers, participants, and technical support staff. We look forward to collaborating and engaging with you in future academic endeavors. Wishing you all the very best in your continued journey in the world of quantum computing. Thank you.
So
Thank
thank you all for your patience and continuous presence. Uh, it was wonderful to get connected to Rathinam College of Arts and Science, and happy to have faculty members from various disciplines. Normally, in my sessions, I have faculty only belonging to computer science. This time, it was from different disciplines of sciences, and because this artificial intelligence claims for multidisciplinary, interdisciplinary, and transdisciplinary, let this be a starting point so that we will be able to interact, collaborate for newer results, newer innovation using quantum computing. So I thank you all for this wonderful, interesting experience. Thank you, everyone. Special thanks.
Thank you, ma'am. We are also enjoy the sessions. Thank you so
Thank
much.
you. Thank you.
Thank you. So thank you all of you for all joining today's sessions. I posted the feedback link in chat. So kindly post your feedback for the today's sessions. Thank you all of you.
So have a great evening. Thank you. Bye. And signing off. Thank you.
Thank you, ma'am.
Thank you, Rajesh sir, for arranging this wonderful FTP. Thank you, sir.